Okay, so here what we are doing is we have already created the this BST initiation. This is the structure of binary search tree. This is just I have created the initiation function. As soon the program search will start, as soon the creation of tree will start. So this function will work on that. Okay. Now I am just creating this root as I need BST so that as soon this will be called, it will go to this function. This function will ask for a number from the user to create a root node, and then it will return that root node as a root value, and that will be stored in root. So now the root of the tree is created. Now we are welcoming for the other values into the tree. So it is asking val1, and here here, as soon this val1 will be entered, will initiate to call this insert BST. Okay, and in this BST, root node will be passed first, and along with that, this val1 that needs to be called, that needs to be um, inserted in the tree, right? So ND will represent the root node and val will represent the val1, or here we'll say new val. Okay, and here we'll pass new val so that you can understand later as well. So now val will represent this new val that is to be inserted. Now, if by any case ND is not there, okay, ND is none. ND is none, capital none. Okay, if ND is none, then what this shows? If ND is none, it means the root node does not exist. So just by chance, if somebody directly calls this function instead of calling this, so what may happen? And that if a root is not there, it means tree does not exist. So if ND is none, it means tree does not exist. Okay, so it will simply return an error. Okay, so it will simply return none. So this is just for a chance that if a tree does not exist, so it will simply return none because nothing exists in the tree now. Okay, if this condition is false, it means the tree is existing. Now what will happen? Now it will check for the data. Okay, so if nd dot data is equal to is equal to val, if both are equal, then now what it shows, it will be duplicate element. Okay, so it will now return. It will just print duplicate
Duplicate.
value, means because binary search tree, every thing is unique in binary search tree. So it will return a duplicate value. If not, then again elif it will check if nd dot data is less than mm, nd dot data is greater than well. So means nd data is greater, then what will it will do is nd dot left is equal to insert BST. Again, we are calling the same function in the recursion. Again, and now it will be called for nd dot left comma with val. Okay,
Okay.
understood. And here also it will return. mm, Let it be. We will check this later. Um, okay. And so this will be called recursively. And if this condition is false, then again elif elif nd dot data is less than val. So at that point, again, nd dot write is equal to insert underscore best nd dot write, and this will be val. Okay. So are you understanding what I am doing?
So if it is the greater than given value, it should be inserted at the left, and then
Yes.
lesser than
So
should be the
as soon I have found that ND of data is greater than given value, it
value.
means it should go at the left side. So it will go on the left. So same function, this function will be called again for the left side.
Okay.
Okay. So it will keep on doing the same process recursively till it found the right value. Okay.
So the second line. Can you explain the second line again? Elif after
This
elif.
one.
Yes.
So what it is means you want this one or this? Sorry.
No, both are same. You can explain anything, but after the elif statement.
Okay. So what it is doing is if ND is not null, ND is not null, that will refer that root node is existing. Now, ND of data means whatever is there as at the root node, that will be compared with this val. Okay. So
Mm-hmm.
ND of data is bigger. So now it means val is smaller than the root node. So now this should go at the left. So ND dot left. At
Mm-hmm.
left of this, again insert BST will be called. So what will happen? Now let's suppose here there is a value. Already somebody has inserted 20 over 20 at the root node. Here, let's suppose somebody has inserted 20, right? So when it will come over here, this condition will be false, and then now at the new value here it has somebody has asked me to insert 16, let's suppose. Okay, so now when this condition will be compared, here it will be comparing with 20 greater than 16. So this condition will be true, right? Now, again, it will be called as ND of left is equal to, and at ND of left, it will be called insert BST again, and ND of left will be called, right? As soon this ND of left will be called, okay. So, what will happen? Just a minute. Here, sorry. Here it will be BST node, VST node, and val will be processed. Okay, so now after
Now I got
getting
it
this
because
condition
there is
true,
returning none. If it is called, there will be again none only, right? That's why I
yes,
was
yes,
asking.
yes,
Okay.
ye-
Okay.
yes. So now and this will be called now ND of left will be working as root node, right? So when it
Mm-hmm.
will be called over here, this will find as none. Okay,
Okay.
so now at that position, this BST node will be inserted.
Okay. Okay.
Okay,
Okay.
understood. Any doubt?
Yes. No, I'm good.
Okay, so this is what is insertion. So what now? What if mm, so I cannot show you this right now because I have still not created the in order, pre-order, and post order. They are for the display purpose. Okay, so let us complete this all, then we'll create those in order, pre-order, and post order. Okay.
Okay.
Okay, so now we'll do this in loop. So
Okay.
what we'll do is we'll take while uh, while insert more. is equal to yes. Okay, and here this will be passed, this will be passed, and here again it will print the message. So it will insert more is equal to input. Do you want to insert more? So I'll do it yes or no. So by this, yeah, and I'll initiate this insert more as yes over here. Okay, so that it can insert. Okay, so now I'll just run this part, just run this first part. nd dot left unexpected indent. Where is unexpected indent? Oh, sorry. This. Yes. So let's execute this. So I am creating this root node as 30 and node for binary search tree. Now I am inserting, let's say, 34. Okay. So do you want to insert more? No, it will come out. I cannot show you that whether it is inserted or not, but the job is being done. Okay.
Okay.
Okay. So now, um, let me create the pre-order and post-order all and anything I'll create. So let me create the pre-order first. Okay,
So yet
let's
was
say
the name. Okay.
sorry,
No, no, no. No, nothing.
let me create the pre-order, define pre-order, and here in for pre-order only one root node will be passed, that will be considered as ND over here. And if ND is none, then return else. So in pre-order, the root element comes first. Okay, so here it will print it. It will be printed nd dot data and end is equal to comma. Okay, and then here I'll define pre-order again. Pre-order, and now pre-order will be called for left of this node dot left, and then again pre-order will be passed as node of right. Okay, so this is done. Now let me call the pre-order here itself. Pre-order, and here I'll pass this through. Okay, so here I am creating a root node as 45 and I am inserting this 90. Okay, so pre-order is not defined because I have not executed this now. Yes, now it will work. So on 45 and 34. So root row node. Oh shit, ND. This is ND 45 and 23. So you can see root node is coming at first, and then in the this is coming. Okay,
Mm,
understood.
mm.
Same way you can create your in order also. So if I create the in order, so this will be in order and this will be between these both. That's it. And post or also let me make everything you will do. And then after that, we'll do the deletion function. So in this,
left the
This
root.
print statement will come at last. Okay, now
This-
let me execute this. And here I'll create the, just you have to call this like pre-order, in order, and post order. Okay, I don't know what's that now. Let me execute this now. Root node 45 and then node for binary search 23. So you can see this is first is the pre-order, and this is these two are the in order, and these two are the post order. So I'll just do the print in front of this all so that it will come um, separate. BST in pre-order. Yes, so root node is 45 and I am now inserting 23.
No,
Um,
how it's
Sorry.
display how it's displaying the results like in the tree? How can we consider this as the tree form? 45 pre-order is okay. First, the root
Hmm.
node will be 45.
Hmm.
Oh, oh, so in order the left node and then the root node, right? And then the right node. Huh?
Yes, yes. So it, okay. I'll insert more. Yes, so I'll insert 89. So you can see here. In pre-order, it is starting with the root node. In post-order, it is ending with the root node. And in order, root node is at middle. Okay.
Okay. So what did you do for the left node?
Uh,
Sorry, right.
Give me a second. Let me organize this little. What is it, your question?
So it is in if the pre-order means root node left and right, right?
Yes.
So how the 89 comes here? What did you do for that? I mean for the right in
89
Inorder
is
and
the the node that I have inserted over here. It is inserted means first 45 was inserted, then 23 was inserted. So 23 came at the left of the 45. and then after that 89 was inserted. So 89 will come at the
Mm.
right of this.
Okay,
So
okay. I did see. Okay.
element order is 45, then 23. So 23 will be at left. Okay. And then 89 came, so 89 will come at the right of 45. So now your structure is looking somewhat like, let me open this paint. I'll just, oh, I'll share this screen. Other screen I'll share. Is this other screen visible?
Yes.
Okay. So now how it is visible is, mm, first of all, 45, 45 came over here at first, right? Then 23 came, so 23 is inserted at the left of this, and then 89 is inserted at right of this. So when there will be pre-order, when there will be pre-order for this, so pre-order is left, root and right. Left, um, so it is left node, then root node, and then right node. So what it will be, left is 23, then 45 will come, and then 89 will come. When there will be in order. So in order is, uh, sorry. What I'm doing, this is not right. So pre-order is, first of all, there is a root, then left, then right.
Right.
And in order, there is first left,
Left to
then
root, right?
root, then right. And then in post order,
Left
first
to
of all,
root,
there is a left, then right, and then
root.
root. Okay. So here
Mm.
in case of pre-order, what will happen? 45 will come at first, then after that 23, and then 89. So
89. Yes.
means the same you saw in pre-order in this. Okay.
Mm-hmm.
And then there will be left, in order. So 23 will come first, root will come at then, and then 89 will come. In case of post order, first of all 23 will come, then 89 will come, and then 45 will come. Means root will come at last. So you can see here in pre-order it is starting with the root node, in post order it is ending with the root node.
Mm.
Okay, so sometimes
Mm.
in the interview, they may ask that this is the pre-order and this is the in order. Um, so can you divide can you find out the root of the tree? So simply by looking at the first element, you can find out the root of the tree. Okay,
Okay.
understood? Any doubt?
No, I'm good.
Okay, okay. So is this another screen is visible? Coding screen.
Yes.
Okay, so like this, you can do the insertion. Okay, and I'll do this again. So you can see again here now. Um, root node is 45, then it is 23, and yes, and inserting 89. So you can see here in pre-order, first of all, root node is there, then left, then right. In order, left, then root, then right. And in post order, left, then right, then root. Okay. Now, do you want to insert more? You can say you can insert more. So let's say I'm inserting as 78. Okay. So now where 78 will come out of all this? Where will be the 78?
70, in pre-order, the 78 will come at 45, at the right side.
So where it will be in pre-order? Just make a tree in your
45,
copy.
45, and then uh, in pre-order, root left and then right, right? So 45, 23, 78, and then 89. Is that correct?
In order where it will be?
Pre-order.
In order where it will be?
In order, left, it's left 45, 23, 45, root, and then right. It's after 45,
Yes. And where it will be in post order?
and then it's left 23, 75, 89, 45.
Yes. Yes. Exactly. Just try to make it in your copy, and you will understand that better.
Okay.
Okay. So you can
Okay.
see here it is in pre-order. Then it is in after between these both, and here it is after 23. Okay.
Okay. Okay.
So now why it is coming after 89? Why it is coming after 89?
Oh, it comes after 89. Root comes after 89. Oh no, right value, right? 1 minute. 40. Where is the value?
It is coming after 89. No, is it coming correct or it is not coming correct?
It should, I think it should come before 89. No?
So 89 is root of 78, correct?
Yes, it's a parent child, is it?
Yes. So 89 is the parent of 78. So parent is coming first in pre-order. That's why 89 is coming first.
Okay. Okay.
Understood?
Yeah, okay.
Okay. Any doubt?
No, no.
So let's insert more so that you can understand that if I am inserting, let's suppose I'm inserting 34. Okay, where 34 will come in pre-order, where 34 will come?
Pre-order. Pre-order 45. Uh, root node and then left 23. 34, 23.
Pre-order.
Oh, no, that's why I'm like 45, 34, 23, 89, 78.
How? First of all,
Mm,
it will be compared with the 45. It is the root node, right? Then
mm.
it will go on the left of this. Then 20, it will be compared with 23. It is bigger than 23, so it will go on the right of 23.
Okay, okay.
Okay.
It's, yeah, then 45, 23, 34. No, it goes 89, 78, and then 34. Is
No, no,
that
no,
so?
no, no. 34 will come between 23 and 89. Okay,
Okay.
understand
So the
this.
root node only be compared, and then the child nodes are, we are not going to compare the value with child node.
Sorry.
So here my question is, what if it is only the given value is big or small will be compared with the root node, not with the child node. Here the
Uh,
45 is compared with
At
34.
at every level, it will be checked. At every node, it will be checked, not just the root node.
Okay, so that it's then it is smaller. Okay, right side it should be smaller, right? Oh no, I
Uh,
will.
let
I'll
me
ask the question. Okay,
let me
show
let
me.
me show you. Let me show you. So right now your tree has it has 45, and it has 23 at the left and 89 at the right, and then after 89 I have also inserted 78 over here. Okay, now when 34 is coming, first of all 34 will be compared with this,
Okay.
right? This is the
Okay.
root node. So now it will be referred to left of this. Now with the recursion, see there was a recursion. With the recursion, again, insert BST will be called, and these two will be compared,
Mm-hmm.
correct? And when it will find that now 34 is bigger, then it will be in this 23 will go at its right, right? So at
Okay.
right there is nothing now, so it has found null. Okay.
Mm-hmm.
So now BST will be called and 34 will be inserted over here. So at every level, it will check whether it is bigger or it is smaller. At every level, this will be checked. This is not
Okay.
just the root
So,
node.
okay, I
Okay.
thought you are
So
telling it comes at the right side. 34 comes at above the 89 likewise. So,
yeah,
okay.
yeah.
No, no,
Okay.
no.
So
Yeah, I got understanding.
now,
It's three.
now understood. Now
Yes.
what will be the pre-order for this? So pre-order is root node first. So in pre-order, there will be um first of all there will be 45. Then there will be
Yes.
23. Then
Okay.
34 will come. Okay. Then 89 will come, and then 78 will come. This will be the pre-order. Okay.
Okay.
Understood?
Okay. Yes. For
Now, um,
in order,
in
89,
order,
89,
in order, first of all, 23 will
3,
come, then
34,
34, then
40,
45, then
89,
78, then
18.
89. This will be the in order. Okay. Then
Why,
there
why,
is the
why not 89, 78, 8? Why not 89, 78?
where in pre-order.
Order.
So in pre-order, root node comes first, now parent comes first. So
No,
89 is the parent of 78.
no, root node, left node, right node is pre-order, and then in order, left node, we are writing left 23 and 34, okay?
Yes.
And then the root node 45, and then the right node, uh, why not 89 and 78? 78 and 89.
So till 45 you are clear in order.
Yes.
Okay. Now it will go to 89. So it will check whether it has its left child or not. So if left child is there, so first that left part will be printed because left is coming first, then root is coming. 89 is the parent of 78. So parent will come after in order. That's why
Mm,
78 is coming
okay.
first.
Okay. Okay. Got it.
Okay.
Mhm.
And yeah, I can understand this seems confusing sometimes. No
No, no,
worries.
no. I have learned this
Yeah.
thing in engineering. I will tell, but it's been a decade, so I'm so it's for everyone, right? So if it isn't, we are not in touch, we won't remember things. So yeah, I can get it, but still, if I have questions, I'm asking.
Engineering also nobody tells in this detail, code
No,
by
no.
code. No one tells.
So data structure, yeah, we did it by and only by after understanding only we did the exams. The same thing we learned, but I don't remember. So yeah.
Okay. In post order, what now? What is there in post order? First of all, left will come, then right will come. So in post order, first of all, there will be 23. then 34, then 78, then 89, and 45 will come at last. Okay.
Mm-hmm. Okay.
Okay. Now one more thing I just wanted to ask. Let's suppose I have just this only. Okay.
Mm-hmm.
I don't have the tree. I don't have anything else. Okay.
Mm-hmm.
Now just tell me, out of these three, how you will you identify that which is in order? How will you identify?
The center one is in order because there is no starting is same, the ending is same in order pre. I mean the pre-order and then the post-order. The starting should be and the ending is starting in pre-order and then root node is starting in the pre-order and the ending is the post-order. That is that the root node is not in the starting or in the ending. So it should be the in order should be in the middle. It will yeah.
Any other thing that you identify? Here you know the tree already. That's why you are telling that middle one is the in order, and you are giving some own logic on that.
Hmm?
But let's say at random place you have just given these three only. Then how will you identify that which one is in order? I am just asking in order, not anything else.
Order. Mhm. Maybe the
I have just these three things only, nothing else.
mhm.
So how will you say that which one is in order? Just try to look at the numbers. You will find this is very easy.
23, 34, 45. Oh, maybe. Oh, okay. So now I have to think that I don't know root and anything, right?
Yes.
So root is in the middle here, and then the values are lower in
Just
the
tell
node.
me how you will identify that no, this is in order. This is just identify the in order in binary search tree. Just think.
23. Mm-hmm.
Shall I tell you?
The only thing I can say here is the right side. I mean the right nodes are it's ascending and descending both sides. Root right and left from this numbers I'm telling.
Okay, so you have to just just look at in order.
Hmm.
In order, numbers are in ascending order. Can you see that? Can you identify that?
Yes. Now, small to big, right? So,
Sorry?
yes, yes, yes. Oh, in order you're telling. Yes, correct.
Yes. So I asked you just to identify the in order. So if you out of these three series, if you just identify the so in order always happens in ascending order.
All
Okay.
right.
So so if you have given all these three things, then just you can say this is the in order. Okay.
Mm-hmm.
And with the
Yes.
in order, you can identify the post order because starting of in order and post order are same. So just you have given these three series. By that you can identify that middle one is in order, lower one is post order because starting off in order and post order is same. So this is 23. Then remaining one will be pre-order.
Oh.
Okay.
Starting of both will be same.
Sorry.
Starting of both will be same.
Yes, starting off in order and post order will be same
Okay.
always
Okay.
because both starts at the left. So you can see here, if you will see, this also
Yes.
starts with left and this also starts with left. So starting
Okay.
of both will be same.
Okay.
Okay.
Mm-hmm.
So there can be multiple this type of questions in the interview that they may ask that these three series are there. Just um, identify which one is the root. What is the root of the tree, right? So how you will identify? You will identify that the series which has the numbers in ascending order is the in order, and series which has the starting same as the in order is the post order. Okay,
Okay. Mm-hmm.
and in post order you have root node at last.
The ending of the
So
pre-order.
sorry,
In pre-order, we have in post-order, the ending node will be the starting node of the pre-order.
ending node will be the root of the tree,
Okay.
right? In pre-order,
Mhm.
root is at starting. In post-order, root is uh, at last. So if you are given with three series, and just by that you are trying to identify. So first you will identify which is in order. Okay. Then
Mhm.
second you will identify from in order. You will identify post order because the starting of in order and post order is same. Okay. And
Okay.
then at third level, you can identify that last of post order is root of the tree. So if you are given three series like this, so just by these three steps, you can identify which is the root of the tree. That's it.
Okay.
Okay,
Okay.
understood.
Yes.
Good. Now let's make a program further. Okay. Is my screen visible?
Yes.
Okay. So now what I'll do is yeah. So this is pre-order, in order, post-order is clear. Now we'll create the values to be removed. Okay, so we'll create the function for that, for removal of that. Okay, so to create the removing function, what we'll do is, first of all, yesterday we saw few scenarios in that. Okay, so how we can do those scenarios? So one by one we'll implement, and then we'll see this further. So def delete binary search tree, and here this node will be there, and del val will take an input from the user at which value is to be deleted. Okay, so now again, if we'll check if nd is none, then then it means tree is not there, so nothing can be deleted. Okay, none. Okay.
Okay.
First of all, we have to perform the search for that. Okay, so this is nd dot data will compare del val is less than nd dot data. So again, we'll do the searching. So del val is smaller, it means it will exist at the left of this. So again, the searching will be performed at the left side. So nd dot left is equal to delete underscore BST, and here now it will be called for nd dot left with del val. Okay, elif del val is greater than nd dot data. It means it is at the right side. So nd dot right is equal to delete underscore bst and nd dot right comma del val. Okay, so this is the traversing till we find the node. Now, if first condition is not true and second condition is not also not true, that means we are standing at the node that is to be deleted. So now we'll do the deletion process. Now it means now it has identified that which node is to be deleted. Okay, so now what we'll do is we'll just identify that which type of this. So there were different scenarios were there at class. What were the scenario? Scenario number one. Scenario number one. What was the scenario number one? Scenario number one was that node has only one child. Okay. So it will be checked if not nd dot left. Okay. If not nd dot left, it means what is it means node has only right child. There is no left child. Okay.
Okay.
Okay. So now what it will do is simply temp
You there?
okay.
Yes. I don't hear in the
Understood.
middle.
Sorry.
Oh, okay. So I don't hear in the middle. It got frozen. The screen got frozen.
Okay. Now am I audible?
Yes.
Okay. Then if it is not having left child, means I'll check elif and not nd dot right. This means node only left child and there is no right child. Okay. So what this will do now? Temp is equal to nd dot left. Okay. And nd is equal to none and return temp. Okay. Then second scenario. Now second scenario will come. In second scenario, node has both left and right child. Okay. Understood? So now it will do nd dot data is equal to, and here what we have to do yesterday in this case, what we no, what we identified when node has both left child or right child. We remember node has both left child and right child. What was to be done?
Node has both left child and right side. It should comes at the uh, I mean right bottom. No.
So
Um,
what we have to do is, In this
Settle it.
case,
Yeah.
either either the biggest element of left subtree or smallest element of right subtree. Okay, either of one value we need to find. So to do this, we have to first of all we have to search the minimum value or maximum value. Okay, so we'll create a node which will do the minimum and maximum value. Okay, so create this. What we'll do, min value node, will create a function that is called min value node. So before this, we'll create this min val node. Okay, so min val node. This is a function to search the minimum value of the left subtree. Okay, so here we'll take uh, current is equal to node nd we are taking, so we'll take the standard specification over here. So nd and then while current dot left is not none, just it will do current is equal to current of left. Okay, and then it will return current. Okay, so by this it will find the minimum value of the left subtree. Okay,
Mm-hmm.
so yes, so now here what we'll do is, and this is done, minimum value is, this part is done. Now simply at the deletion statement, in the deletion, we'll pass where it is, yeah. So here we'll pass function min val node. Here we'll pass minimum value of left subtree. Yes, yes. So here this will be passed as nd dot right, node dot right dot data. Okay, and then nd dot right is equal to delete underscore bs dot data. Okay, understood. This is a understood. Let us execute this, then we'll see how this is working.
So for
Let
me, it got freezed. So nd.data. Oh, now only it's displaying. Okay. Yeah, go ahead and do it. You hear me? I don't hear you.
can you hear
You
me?
hear me?
Yes, yes,
Yeah,
I can hear you.
yeah. Now only I can hear you. Yeah.
Del val is equal to integer input. Enter the node to be deleted. Okay, then here delete BST will be called over here. Now delete underscore BST will be done, and root and will print preorder in order and post order. Okay. Anything else is required? No. Okay, so let's create a some node. Do you want? Just okay. I'll execute this now. So I am creating a root node with 56. Let's create something, some more elements. So I'm taking this 35, and then I'm yes. So I'm taking this 89. Yes, I'm taking this 44, and then I'm taking this 70, and yes, I'm taking this 76. Okay, enter the node to be deleted. I have entered. Okay, no, I don't want to delete more. Okay, okay. So now we have created this tree, and in this tree um, we have elements like 56, 45, 23, 89, 65, 44, and 60. And now I don't want to insert more. Now I'll start deleting. So let us visualize this in how it is working in our diagram. We'll see how it is working now. Give me a second. Okay, you. Why it is not coming in proper way? Why it's coming in half the screen? Okay,
Mm.
so now first of all we inserted 56. So right now 56 is the root node. Then we inserted 45. 45 came over here. Then we inserted 23. 23 came over here. And then we inserted 89. So 89 came over here. And then we inserted 65. So 65 will come over here. And then we inserted 44. So 44 will come here. Okay. And then
Okay.
we inserted 60. So 60 will come here, right?
Okay.
So this is our tree right now. Okay.
Okay.
Okay. So now let's suppose I am inserting this. I am deleting this 65. Okay. So
Mm-hmm.
let me delete the 65 from here. So 65 from here, it will go off, right? So after removal of 65, this 60 will be attached with the 89. Okay, so I'll just remove this 60, and you can see here 60 is removed from here. No, not only 60. So more are also removed. Also not coming.
Are you doing? I don't see the screen.
Okay, sorry. Sorry, my computer screen is disconnected. Let me connect that again. Not again, please.